Today we are going to discuss something called the law of sines. The law of sines is essentially a way to find missing parts of a triangle, even when it's not a right triangle. So before we do that, though, we're actually going to take a look at also just another formula for area of a triangle. And then by using that formula, we're going to develop the law of sines. So one thing to keep in mind with this unit, as we do what's called the law of sines and the law of cosines, is that we are actually going to be in degree mode a lot. So I know that usually we're in radian mode, but we are going to use our calculator quite a bit for this next few days, and you want to make sure you're in degree mode. So just keep that in mind. So of course we all know that the area of a triangle is 1/2 base times height, right? But what if we don't know the height, right? A lot of times that's not something that we know. So the question then becomes, well, what could we do? So if I wanted to find the area of this triangle and I don't know the height, one thing that I could do is drop in an altitude, right? I could drop in the height. So we have lots of options, right? Like you could drop it in here, right? Or we could drop it in here, right? Any of those would work, right? Right angle. But I think based on what we have, we're probably best off dropping it in this direction. And so if we drop that altitude in and we've got that little right angle there, right, then we know that that makes the base of the triangle this one over here because it's perpendicular. So my area is going to be 1/2 the base times the height. So the area is 1/2, and then we've got 9, and of course the problem is we don't know h, right? So then the question becomes, well, how could we get h? And so if we look at what we do have, since we have a little right triangle right here, and we know that this side here is 12, and we know that this is 80, right? Then looking at that little right triangle, we know that the sine of 80 degrees is the opposite, which in this case is our height, over our hypotenuse, which is 12. So for that little right triangle, the h is actually the opposite side, and the hypotenuse is 12. So that means then that h equals 12 sine 80 degrees. So we can come up here and put that in. So we have 12 sine of 80 degrees. And so then our answer ends up being whatever the heck that turns out to be. So if I come in here, oops, I want notability, grab the wrong thing. Oh boy. Yeah, that's not what I want. There we go. Gonna need Desmos. You can use your calculator. I would highly recommend that you get your calculator charged up if it's not already, because you're going to use it a lot. One thing also, if you are using Desmos, just because your calculator is dead, Desmos is automatically in radian mode, so you need to click up here on the little wrench and change it to degree mode, okay? And if you close out of it, when it reopens, it'll be back in radian mode, so you always want to check that up there, okay? All right, so we've got 0.5 times 9 times 12 times the sine of 80. So we got sine of 80. And so our area turns out to be about 53.2. 53.2. And we were in inches, so inches squared. There we go. Right. So can we generalize that? Okay. So what if we could come up with a new formula for area of a triangle using what we just did? Right. So if I were to come in here and once again drop that down, make my little right angle there, then I know that the area is 1/2 the base b times the height h, right? But the height h, so if I took again the sine of, in this case, angle C, right? That would be h over little a. So my height is a sine C. So there it is, a sine of angle C. And so a lot of times how you'll see this written is just in alphabetical order. It'll be 1/2 AB sine of C. And so we actually have a new formula for the area of a triangle. Now, one thing to keep in mind is that the letters don't really matter. It's really all about the position. So if you look at this formula, where is side A and side B and angle C? Well, angle C is always, the angle C that we're dealing with is in between A and B. So it's like A and B are the flippers. So I always refer to this as like the seal. So you've got the flippers, right? And then there's your angle in between them. So that means that we can write this formula, like for example, let's say instead we wanted to use angle B. Then we could have the sine of angle B, and we'd have 1/2, but then now if angle B is the angle in between, then that makes the flippers little a and little c, right? So that would be another way to write it. Or we could say the area is 1/2, and so we could do the sine of angle C, right? And so now, or sorry, we already did C, never mind. Sine of angle A. Be careful, this A is area over here, right? And this is angle A. So the sine of angle A, and our flippers then are B and C. So 1/2 BC, sine of A. So there's another way to write it. So when you go to find the area, right, you're really just thinking of it as it's 1/2, and then I've got the flippers and the sine of the angle in between them. So how does this help us figure out the law of sines? Well, if this is 3 different ways to write the area of the same triangle, then that means that they're all equal, right? So if I were to set all of these things equal to each other, right, then I can multiply everything by 2, and my 1/2s all cancel out, right? And so I'm left with B times C times the sine of angle A equals A times C times the sine of angle B equals A times B times the sine of angle C. And then what I can do is divide all of them by little a, little b, little c. So if I divide everything by those sides, then notice what happens. So in the first part, the b's cancel, the c's cancel over here, a's and c's. Here, the a's and the b's. And by golly, what we're left with is what's called the law of sines. And what the law of sines says is that I can take the sine of an angle divided by the side length that's across from it, and it will be in proportion to the sine of a different angle over the side across from it. So the main thing to remember when you're labeling these triangles, and I probably should have mentioned this up here, right, is that if this is little a, then the angle across from it is angle big A. So we use little letters for the sides, and we use big letters for the angles, right? So big B is across from side B, little b, okay? So what that means is any triangle has this proportionality. And that's super, super powerful because we can use this, and it doesn't have to be a right triangle, right? So normal trig, sine, cosine, tangent, we're always dealing with right triangles. We do not have to have a right triangle. Now, you might think back to geometry, right? And so back in geometry, when we talked about proving triangles congruent, you had the 4 different cases, right? Side, 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 angle, side, angle, side, angle, 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 side. So when you're talking about the law of sines, we're going to use that when we have angle, side, angle, and angle, angle, side. And when we learn the law of cosines, that's going to take care of the other 2. So notice that we never have a law of tangents. There is a law of tangents. It's really messy, it's really gross, but we never use it because we don't need it, because the law of sines and the law of cosines take care of everything because they take care of the 4 cases. Now, rather than try to memorize, okay, law of sines goes with these 2, right? Usually what I do is I just look at the situation and see if I can indeed get a proportionality. So as long as I can do a proportion, I can use the law of sines, right? When you see this phrase, solve the triangle, that means that you're finding anything that's missing. So any missing sides and angles, that's what it means to solve the triangle, okay? So when you look at this one, at first you might think, well, I can't use the law of sines because I've got an angle, but I don't know the side across from it. I've got this angle. I don't know the side across from it. I have this side, but I don't know the angle across from it. However, that third angle is super easy to find, right? Because we know that in a triangle, all those angles should add up to 180, right? So all we have to do, whoop, boop. Not that I couldn't do this subtracting in my head, but I just wanted to write it out for us here, right? So I can simply do 180 minus the 28, and then minus my 75, and I'm left with 77 degrees. So 180 degrees minus 28 degrees minus 75 degrees is my 77. And so now that I have that, I can set up a law of sines. So the law of sines says I take the sine of angle 77 over 10, right? Because I know those two. So the sine of angle 77 degrees divided by 10 is equal to, and then I can pick. So actually I can decide which one of these I want to do first. So let's say I wanted to find little z first. Then I can do the sine of 75 over little z, because they're across from each other in the triangle. And so now to solve this, I can just cross multiply. So I'd have z sine of 77 degrees equals 10 sine of 75 degrees. Divide by the sine of 77. And so z is 10 sine 75 over sine 77. Right? And so that means I got to get out my old Desimos again here. I should just leave it open, I suppose. Okay, so we've got 10. And then the sine of 75. And then we're going to divide that by the sine of 77. And we get 9.91. Let's see what I say to round to. Round to the nearest 0.1, so 9.9. So there we go. So 9.9 centimeters. We actually already have angle x, right? We said that was 77 degrees. So the only thing left to do is find y. Now, the biggest mistake I see is people go, oh, I'll just use the Pythagorean theorem. We can't, right? Remember, this is not a right triangle. So we have to set up the proportion again, right? So we have to say the sine of 77 over 10, and now we'll do the sine of 28 over little y. Right? So this is sine little y. So we have to go through that process again. We can't just use the Pythagorean theorem. The other thing I would highly suggest going back and using the proportion that was given to you, rather than, you could technically now use the sine of 75 over the z value you got, but if you accidentally typed in the z wrong, right, then you're going to compound your mistake. So I would probably go back to the original one, since that one is, true, sine of 77 degrees over 10. All right, so when I cross multiply, I've got y sine of 77 equals 10 sine of 28. So y equals 10 sine of 28 over the sine of 77. And so actually I can just come in here and change that angle up there to 28. And so I've got 4.8. There we go. So there's y. Now, one thing that's a super quick check is that if you've done it right, the smallest angle should be across from the smallest side. So 4.8 is the smallest side, right? And then the biggest angle, which was 77, is across from 10. And then 75, which is really close to 77, is across from the 9.9. So that makes sense. They're about the same, but it is a little less, right? And then last but not least, let's use that new area formula that we learned, right? So the area we know is 1/2, and then I just pick two flippers, right? And this is, again, totally up to you. Pick any two flippers, and then you've got the sine of an angle. So let's say we want to use angle 75. So if we're going to use angle 75, then the flippers, right, are these two sides. So we're going to use the 4.8 and the 10. So we got 4.8 and we've got 10. So let's see, we got 0.5 times 4.8 times 10 times the sine of 75. 23.18. Now, one thing to note, let's say you decided to use a different angle, like maybe you did 28, and then you use the z and the 10. Your answer here for the area could be slightly different because we had to round the little z and the little y, right? And so that compounding error might be off. So if you really wanted an accurate area, you would want to keep more decimals for your side lengths. So, all right. Let us do one more here. This is the other case. Now, one thing, notice they didn't draw the picture here. The beautiful thing about the law of sines and then the law of cosines is we really do not have to have a very accurate drawing. Now, that being said, I do usually say, okay, if this is an obtuse angle, I should probably make sure that that's the obtuse one. So we'll make that 105. So as soon as that is angle P, then that means little p has to go across from it. So when you label it, you just need to make sure you have it labeled like that. So then if this is Q, they told us it's 25 degrees. Right? And so little q would be over here. We don't know little q. And then that would be, what's the other angle? It looks like they're calling the other one R here, right? So we'll call this R, and this is the law. So notice that here's a case where we actually have angle, angle, side, right? So we have the angle, and the side here. So we actually can go straight into the law of sines. Now, we still need to find angle R because we're going to need it later, okay? But we could go right into the law of sines here because we know an angle across from a side. And then we could get little q, right? So right off the bat here, we can jump right in and do the sine of 105 divided by 15 is going to equal the sine of 25 over q. All right, cross multiply, so we'd have 15 sine 25. Of course, you get good at this. You realize that sine 105 is always just going to end up underneath, right? Don't do what I see some students do, which is somehow think that you can cancel the signs. That would be a sin. Don't do that, right? Those do not cancel. Okay, so let me erase that so we don't think that they do. All right, so we gotta actually punch it all in. Right, so we got the sine of 105. Okay, so we've got 15. The hardest thing about the law of sines and cosines is just typing everything into your calculator. It just takes forever. 15 sine 25 divided by the sine of 105. Doopy-doo. 6.6 if we round. So Q is about 6.6. Okay, which I think is what I said to round to. Yep, so 6.6. We can go ahead and get angle R there, right? So angle R is going to be 180 minus 105 minus 25, so 50. Right, so angle R is 50 degrees. And that is necessary because now to set up that law of sines again, we need to, I won't that scoot over any further. I don't know, so I guess I'll just do it over here. Oh, hi, Cheeto. You coming to visit? Okay, I'll let you in. You can say hi. You gonna do some meowing for us? Okay, so we've got the sine of angle R is 50 divided by little r. And then we've got the sine of, and again, I like to go back to the one that was given to me. So I like to go back to the 105 over 15. So when I cross multiply, then I'm going to have 15 sine 50 over sine 105 equals r. Oh, you're fine, Cheeto. All right, so then we can scooch back up here and actually just change that 25 to a 50, and I get 11.9. So there we go, 11.9. All right. And then again, the great thing is with the area, I have a choice. Now that I have all of the angles and sides, it's totally up to me which one I want to use. So let's say I decide to use the 25 there. So then I would have the area is equal to 1/2. I've got a leg. I've got another leg. So again, I pick the flippers, right? So in this case, the ones around the 25 are the 15, and then the R value, which we found out was 11.9. Right. Scooch that over just a little bit. And then I've got the sine of angle R, which was 25 degrees. So then I can just come in here. I've got 0.5 times 15 times 11.9 times the sine of 25. So my area is about 37.72. And what are we doing here units wise? Centimeters squared, right? There we go. All right. So I got 37. Oh, actually, I just noticed this was in feet. And that says centimeters here. Actually, it's feet, isn't it? Feet squared. 37.72 feet squared. 37.72 feet squared, because we were in feet. All right, so I think that should do it for you. So there are some problems to try, and just to get some practice with it. So the law of sines is typically pretty straightforward for folks. It's just knowing that proportionality and then learning that new area formula, which is really quite helpful. So then after this, you're going to learn the law of cosines tomorrow, which is a little more complex, but still a wonderful, wonderful formula. And that should do it.